Have you ever examined whether we're truly alone in the universe? Then again, have you thought about the possibility that there may be something more to our reality than what we see? Envision what might occur if the James Webb Space Telescope finally showed that we live inside a black hole. It could change everything. As we delve into this fundamental discovery, it may make you question everything you thought you knew about the universe. So, what exactly are black holes? They're like something out of a nightmare. Sure, you've seen them in sci-fi movies, but incredibly, they're real and truly terrifying. Experts have demonstrated that black holes in space are thought to contain enormous amounts of matter compressed into a tiny region. Imagine a star much larger than the Sun compressed into a sphere the size of New York City. The gravitational pull is so strong that nothing, not even light, can escape it. Scientists have been fascinated by black holes for decades. They've studied objects in space so massive and dense that they trap light. The most notable theories about black holes were predicted by Einstein's theory of general relativity. Essentially, when a massive star collapses, it leaves behind a dense core. If this core's mass is a few times greater than the Sun, gravity overwhelms everything, leading to the formation of a black hole. Detecting black holes is no easy task since they don't emit light. However, researchers have found ways to infer their presence by observing their effects on nearby matter. For instance, if a black hole passes through a cloud of interstellar matter, it pulls that matter toward it in a process called accretion. Additionally, when a normal star gets too close to a black hole, it can be destroyed and emit X-rays in the process. Black holes also have immense effects on their surroundings. They can consume nearby stars, emit powerful radiation, and even influence the formation of new stars, sometimes slowing it down in certain regions. But where do black holes come from? Imagine stars, once massive and powerful, meeting their violent end in a colossal event known as a supernova. From the remnants of these fallen giants, black holes emerge. Most black holes are born from massive stars that have reached the end of their life in a supernova explosion. Smaller stars, when they die, transform into neutron stars, extremely dense but not dense enough to trap light. However, if a star's mass is several times that of our Sun, it collapses under its gravitational force, forming a black hole. During these collapses, something strange happens near their surfaces. Time itself begins to behave oddly. From the perspective of someone far away, time appears to slow down near the event horizon, the final boundary before anything falls into a black hole. Occasionally, when two smaller black holes collide, they merge to form an even larger and more terrifying black hole. If a black hole interacts with a neutron star, they create a massive phenomenon that defies comprehension. Scientists have been studying the size of these gigantic phenomena for years. Black holes come in two sizes, large and small. There's a mysterious allure surrounding them that we can't fully unravel. However, small is relative when it comes to black holes. Large black holes, the remnants of giant stars, can be 10 to 20 times the size of the Sun. There may be as many as 10 million to a billion of them in the Milky Way alone, a staggering number of black holes capable of consuming anything in their path. But wait, there's something even more massive: supermassive black holes. These are at the extreme end of the spectrum and are millions, if not billions, of times larger than the Sun. They exist at the centers of massive galaxies, including our own Milky Way. It's like a colossal dead space pulling everything toward it. The renowned physicist Stephen Hawking spent much of his life discussing black holes. His lectures were always captivating, yet some of his theories couldn't be confirmed due to the lack of advanced equipment. However, there's hope on the horizon. A single scientific instrument is making a huge difference: the James Webb Space Telescope, JWST. This is no ordinary telescope. It's an engineering marvel and a testament to human ingenuity. While we've launched other space telescopes before, and they've done well, this powerhouse is truly extraordinary. The JWST makes the Hubble Space Telescope, our previous workhorse, seem like a mere dot in the universe. This cosmic marvel cost a staggering $10 billion and took the combined efforts of NASA, the European Space Agency, and the Canadian Space Agency to bring it to life, along with contributions from over 300 universities. However, such an ambitious undertaking comes with its risks. The JWST is venturing into uncharted territory, pushing the limits of what we know and taking us to places we've only dreamed of. Since its launch, the JWST has achieved incredible milestones. It traveled over 1 million miles to its orbit around the Sun, where it will remain indefinitely. During its journey, the telescope successfully deployed its massive 5-layer sun shield and giant primary mirror, both of which had to be folded to fit inside the launch vehicle. Now, after NASA adjusted and calibrated it, the telescope is almost ready for full operation. One of the most awe-inspiring moments was when NASA announced that the telescope had captured its first images of starlight. The first image was of a star called HD 8446, resulting in a mosaic of 18 bright spots from the light captured by the 18 mirror segments. NASA later released another stunning image of HD 8446, with the 18 images combined into a hexagonal design. Once the observatory fully aligns its primary mirror segments, it will begin stacking images into one clear view. Thanks to its advanced technology, the JWST will help scientists study the early stages of the universe after the Big Bang. It will focus on what happened after the first stars formed during a period called the Epoch of Reionization. The JWST will also assist in finding exoplanets, observing their atmospheres, and determining their conditions to predict whether they might be habitable. Moreover, it will help scientists understand the structure of matter on a large scale and how galaxies evolved over billions of years. Most importantly, the James Webb Space Telescope will help us answer the ultimate questions. Are we alone in the universe? And are we living inside a black hole? The JWST, equipped with cutting-edge technology, allows it to observe the universe in extraordinary detail. Its advanced infrared sensors can detect the faintest light from the farthest reaches of the universe, revealing phenomena previously invisible to us. One of its key missions is to peer back in time to the universe's earliest days by observing the first galaxies that formed after the Big Bang. The JWST will provide insights into how matter began to organize itself, ultimately leading to the complex structures we see today. This exploration will help scientists understand the origins of stars, galaxies, and even the building blocks of life. The telescope's powerful instruments are also designed to study exoplanets, planets outside our solar system. It will analyze their atmospheres, looking for chemical signatures that may indicate the presence of life. Imagine the implications of finding a planet with water, oxygen, or other biomarkers. It could fundamentally change our understanding of life's potential in the universe. The James Webb Space Telescope, JWST, is poised to provide answers to this age-old question. Its ability to detect faint signals from the depths of space might reveal signs of life, or even other civilizations. Beyond that, it could help us understand whether our universe is part of something much larger or more complex, such as a multiverse or an interconnected web of realities. If we consider the possibility that we might live inside a black hole, as some theoretical physicists have speculated, it opens up profound questions about the nature of existence itself. Black holes, with their extreme densities and gravity, warp space and time in ways that defy our understanding. Could our entire universe be the result of the collapse of a star in another, larger universe? This idea, though speculative, has fascinating implications. For instance, the singularity at the center of a black hole could serve as the seed for a new universe, creating a self-replicating cycle of cosmic creation. If this is true, then black holes in our universe could themselves be the birthplaces of other universes, a concept that challenges our perception of beginnings and endings. The JWST might not directly confirm such theories, but it can provide valuable data that pushes the boundaries of our knowledge. By observing the behavior of matter near black holes, mapping the earliest structures of the universe, and identifying patterns in cosmic evolution, it could help validate or refute ideas that have remained purely theoretical for decades. Meanwhile, The telescope's search for exoplanets continues to spark hope and curiosity. Discovering Earth-like planets with atmospheres that contain water vapor, oxygen, or other life-supporting compounds would be a monumental step toward answering the question of whether we are alone. Scientists estimate there are billions of exoplanets in our galaxy alone, many of which lie in the so-called habitable zone where conditions might support life. What would it mean for humanity to find even microbial life on another planet? Such a discovery would confirm that life is not unique to Earth and could arise under the right conditions elsewhere. If, on the other hand, the JWST finds no evidence of life despite exhaustive searching, it would underscore the extraordinary rarity of our existence and the need to protect and cherish our planet. The implications of the JWST's findings are not limited to science. They extend into philosophy, religion, and the very way we view ourselves. Are we a cosmic accident or part of a grand design? Are we destined to explore and populate the stars? Or is Earth our only home? Regardless of the answers, the James Webb Space Telescope represents a triumph of human ingenuity and curiosity. Its discoveries will shape the way we understand our place in the cosmos for generations to come. By reaching into the vastness of space and time, it reminds us of the boundless potential of human exploration and the endless mysteries that await us in the universe. For hundreds of years, the JWST could not just bring us nearer to responding to that inquiry, but could also redefine our position in the universe. Assuming it finds evidence of other civilizations, even microbial life, it would be one of the most significant discoveries in history. And then there's the question of whether we might be living inside a black hole. This idea, once considered science fiction, has gained momentum among certain physicists. They hypothesize that our universe could be a bubble inside a larger structure, possibly inside a black hole. The JWST's capacity to observe the universe at an unprecedented scale could provide clues to this mind-bending speculation. As the telescope continues its mission, the data it gathers will be analyzed by scientists worldwide. Each new picture, each new discovery will bring us closer to answering the greatest questions of all. Where did we come from? What are we doing here? Furthermore, what is the ultimate nature of reality? The James Webb Space Telescope represents the pinnacle of human creativity and curiosity. It is a symbol of what we can achieve when we dare to dream big and collaborate. Its journey has just begun, and the discoveries it will unveil may reshape our understanding of the universe and ourselves for many years to come. As of now, I have been on this pursuit, pondering what has been found. Compounds called polycyclic aromatic hydrocarbons, PAHs, are hiding near massive, particularly immense black holes in 3 unique galaxies. These carbon-based particles with ring-like structures are the goth kids of the universe. They're everywhere from distant galaxies to comets, and even in our own nearby planetary system. PAHs are not just fascinating because they could be the building blocks of life, but also because they help researchers trace star evolution. When ultraviolet radiation hits these PAHs, they glow and emit infrared light, a signal detectable by the JWST's mid-infrared instrument. This is often a sign that there are hot, young stars nearby. However, there's a twist. A curious astrophysicist, Isel Garcia Bernard from Oxford University, decided to focus on 3 powerful galaxies: NGC 6552, NGC 70319, and the famous Stephan's Quintet, located millions of light-years away in the depths of space. What Garcia Bernard found was chilling. In the central regions where the black holes dominate, he discovered a high concentration of PAHs. Sounds fascinating, right? Well, here's where it gets eerie. The radiation near these colossal black holes distorted the PAHs, essentially transforming them into larger, electrically neutral versions of themselves. The smaller, electrically charged PAHs disappeared into the void, as though consumed by the abyss itself. But wait, there's a glimmer of hope, or perhaps not. The real question here isn't whether we're alive, but whether we truly exist. Does everything around us exist because of the black hole we're in? Everything seems to align with the hypothesis that we might not just be living inside a black hole, but rather within the event horizon a boundary between the universe we know and the unknown. Could it be that everything is interconnected inside a black hole? The James Webb Space Telescope is out there right now, searching for answers to the unknown. Stay tuned, and perhaps it will make us all reconsider what we thought we knew about existence. Reality may be more curved than we realize. In the fascinating universe of astronomy, few topics have sparked as much intrigue and mystery as black holes. These monstrous entities, with their ability to warp space-time and consume everything in their vicinity, have long been the subject of both scientific study and popular imagination. The revelation that we might finally uncover what's inside a black hole, proposed by the renowned physicist Michio Kaku, plays on the wonder and curiosity surrounding these enigmatic objects. But what does this bold claim mean? Has science finally unlocked the secrets of what lies within the event horizon of a black hole? To understand Kaku's statement, we need to step back and examine the concept of black holes, the current state of research, and the implications of the latest discoveries in the field. A black hole is a region in space where the gravitational force is so strong that not even light can escape it. This phenomenon results from a massive star collapsing under its own gravity after exhausting its nuclear fuel. When this happens, the star's core contracts, and if the mass is great enough, it forms a singularity, a point of infinite density where the laws of physics as we know them break down. Surrounding this singularity is the event horizon, the boundary beyond which nothing can escape, not even light. For years, the existence of black holes was purely theoretical. The concept first emerged from Albert Einstein's general theory of relativity. However, it wasn't until the 1960s and 1970s that scientists like John Wheeler, Roger Penrose, and Stephen Hawking began developing the mathematical framework that brought black holes into the realm of accepted science. Even with this theoretical understanding, black holes remained a subject of mystery and speculation. What happens beyond the event horizon? Is it possible to peer inside a black hole? Or is it forever inaccessible? The event horizon of a black hole represents a point of no return. Once something crosses this threshold, it is inevitably drawn toward the singularity at the center, where it is crushed to infinite density. Despite their importance in the black hole model, the event horizon is not something we can directly observe. The very nature of a black hole means that light cannot escape its gravitational pull, making the study of what lies beyond the event horizon incredibly challenging. For years, black holes were thought of as vast prisons where information about the objects falling into them would be lost forever. This idea was encapsulated by the so-called information paradox, which emerged from Stephen Hawking's work in the 1970s. Hawking proposed that black holes could slowly evaporate due to a process known as Hawking radiation, a quantum phenomenon suggesting that black holes gradually lose mass over time. If this radiation carried away all the information about what had fallen into the black hole, it would violate a fundamental principle of quantum mechanics, known as unitarity, which states that information must be preserved. This paradox ignited decades of debate, with some arguing that information lost in a black hole could never be recovered, while others suggested that the information was not lost, but merely hidden in a way we could not yet comprehend. Recent advancements in theoretical physics and quantum mechanics have led to new insights into this paradox. Some scientists propose that information may be preserved in the form of quantum entanglement at the event horizon, a theory known as the holographic principle. This principle suggests that all the information about an object falling into a black hole may be encoded on the boundary of the event horizon itself, much like a hologram. The details of the object are not physically lost, but rather transformed in ways we cannot currently detect. These groundbreaking theories challenge our fundamental understanding of space-time and information. They suggest that even in the most extreme conditions, such as inside a black hole, the rules of the universe may not be as straightforward as we once believed. The study of black holes isn't just a scientific endeavor. It also holds the power to transform our philosophical and existential understanding of reality. Black holes challenge our perception of time, space, and causality. They force us to confront the limits of human knowledge and the boundaries of our comprehension. One of the most intriguing aspects of black holes is their connection to time itself. As objects approach the event horizon, time for them slows relative to an outside observer due to intense gravitational time dilation. This phenomenon suggests that, in some sense, black holes are windows into the distant future. They may hold secrets about the ultimate fate of the universe, offering insights into cosmic evolution on incomprehensible timescales. Moreover, black holes have become laboratories for testing the theories of quantum gravity, a field that seeks to reconcile Einstein's general relativity with quantum mechanics. Resolving these conflicts is essential for understanding the fundamental workings of the cosmos. Perhaps black holes hold the key to a long-sought theory of everything, uniting the forces of nature under a single framework. The James Webb Space Telescope, with its unparalleled capabilities, has already begun to revolutionize our understanding of the universe's most enigmatic phenomena. By peering into the hearts of galaxies, JWST can study the interactions between black holes and their environments, shedding light on how they shape and influence the cosmos. One of the most remarkable observations made by JWST involves the role of supermassive black holes in galaxy formation. These behemoths, millions to billions of times the mass of our Sun, are thought to reside at the centers of most galaxies, including our own Milky Way. Their immense gravitational pull draws in gas, dust, and stars, forming swirling accretion disks that emit staggering amounts of energy. This energy, in turn, drives powerful jets and winds that regulate star formation, demonstrating that black holes are not merely destructive forces, but also creators and sculptors of cosmic structures. Yet the questions persist. What happens inside a black hole? Is it a gateway to another universe, as some theories propose? Could the singularity at the core of a black hole be a portal to another dimension, or even the seed of a new universe? These ideas, once relegated to the realm of speculative fiction, are now being taken seriously by physicists exploring the cutting edge of theoretical science. The concept of black holes as cosmic bridges, wormholes connecting different regions of space-time, is a tantalizing possibility that could rewrite the rules of physics. In parallel, the holographic principle offers a striking reinterpretation of reality itself. If all the information about our universe can be encoded on a two-dimensional surface, then our three-dimensional experience of reality might be a projection, a cosmic illusion on the grandest scale. This idea, though abstract, aligns with observations and experiments that suggest space-time may not be as continuous or smooth as it appears. As the James Webb Space Telescope continues its mission, humanity stands on the brink of a new era of discovery. The telescope's ability to capture light from the earliest moments of the universe's history, combined with its precision in observing distant galaxies and black holes, will undoubtedly yield groundbreaking insights. Each image it sends back expands our horizons, not only scientifically, but also emotionally and philosophically. The mysteries of black holes, intertwined with the broader questions of existence, compel us to keep pushing the boundaries of what we know. They remind us that the universe is a place of infinite wonder, and that our quest to understand it is as much about exploring ourselves as it is about exploring the stars. The future of black hole research will likely involve even more advanced technologies, such as quantum sensors, gravitational wave observatories, and perhaps even spacecraft capable of venturing closer to these cosmic giants than ever before. As we develop new tools and theories, we may uncover answers to questions we have yet to imagine. For now, the James Webb Space Telescope stands as a beacon of hope and curiosity, a testament to humanity's relentless drive to seek knowledge. It promises to unlock the secrets of the cosmos, challenge our preconceptions, and inspire generations to come. The story of black holes is far from over. It is a narrative of discovery, of bold ideas, and of a universe that refuses to reveal its secrets easily. Yet, with each step forward, we come closer to understanding the profound interconnectedness of everything. And perhaps, one day, we will look into the heart of a black hole and find not just the answers we seek, but also new questions to ignite our imagination and propel us into the next chapter of our cosmic journey.